amigos. They're all used for projectile motion, and in this, the first amigo, you have VF, which stands for velocity final. VO, which is velocity initial. And then A and T, which stands for acceleration and time.
The missing variable in this equation is either delta x or delta y, which is the displacement of the projectile. So you can use this equation to find all of the different variables that Jerome said, which is VF, velocity final, VO, which is velocity initial, acceleration, and time. But you can't use it to find displacement.
Okay, we're going to do our first example, and we're just going to pretend that we push Felipe off a cliff. He weighs 136 kilograms, and if he falls vertically, what will his final velocity be after 3 seconds of free fall? So, Felipe weighs 136 kilograms. His velocity initial is 0 meters per second, and this is all in the y direction. We're trying to find his final velocity. That's what we don't know. The time of his free fall is 3 seconds, and acceleration due to gravity is 9.8 meters per second squared. This is always the same number. So what we do is we set up our equation, VF equals V naught plus acceleration times time. And this is what we're trying to find. So then we plug in every other variable into the equation. So V naught, 0, plus 9.8 due to gravity for 3 seconds. Time always has to be in seconds. We take out a calculator, do 9.8 times 3, and this will be his velocity final is 29.4 meters per second.
Okay, so our next example is going to be, let's assume Felipe, the manager of the soccer team, is running to get Jairo and Jerome some water after a big game. He starts from rest on the sidelines and reaches a speed of 1 meters per second after 20 seconds, and we're going to calculate his acceleration.
All right, so example number 2, we're going to start out by writing all of our givens. So we have velocity initial, which is 0, our velocity final, which is going to be 1 meter per second. Then we also have acceleration, which is what we're solving for, and his time is going to be 20 seconds. So we're going to start out by writing our equation, VF equals V naught plus AT. And like Jairo said, we're just going to plug in all of our values. So VF, that's going to be 1 meter per second. VO, that's going to be 0, plus acceleration is what we're solving for, and then time, which is 20 seconds. So as you can see, all we have to do is divide 20 out from this side of the equation. So then acceleration is equal to, pull out our calculator, 0.05 meters per second squared.
Okay, before we get into the third example, it's really important that we recognize this special relationship between acceleration and velocity. If acceleration is counteracting the velocity, then the acceleration has to be negative. So let's go into example 3. In example 3, we have Felipe being shot up out of a cannon. So let's draw this picture right here. Boom, boom, boom. And Felipe is going this way. He's going that way. Acceleration due to gravity is still 9.8 meters per second. squared. And his velocity right now is going up, but his acceleration is still in the negative direction, counteracting his velocity. In the second example, Felipe was running, let's say to the right, and that was his velocity, and his acceleration was also to the right. So that's why they were both positive. And up here, he was falling down, which means his velocity was down, and his acceleration was also down. So they weren't counteracting, and they were both positive. Here, acceleration is opposite to velocity. So the acceleration is actually going to be negative 9.8 meters per second. His velocity initial is 300 meters per second. And we are trying to find his time before he starts coming back down. So that means that his velocity final at the top is 0 meters per second, because at the top up here there will be one split moment where he will be completely still in air before coming back down. So we're going to set up our equation. Velocity final v naught looks acceleration times time. His velocity final is 0. His initial is 300. Now his acceleration is going to be negative 9.8 meters per second squared. And his time is what we're trying to find. So we go negative 300. This is simple algebra right here. To both sides is negative 9.8 times time. Divide both sides by negative 9.8. And his time before reaching the very top of his projection is going to be 300 divided by 9.8. Which will be 30.612 seconds.